All right, welcome back, everyone. We have another great session here on the architecture track with two Marcs, one from Solace and one from AWS, and my colleague and good friend Oleg. And they're going to be telling us all about Spring Cloud Function, where we are currently, and giving us a sneak peek into the future as well. So I'll turn it over to them.
Hello, everybody. My name is Oleg, and I am project lead for Spring Cloud Function and Spring Cloud Stream. Quickly about myself, I've been with Spring organization since 2008, pretty much done a lot of different things, primarily one of the core engineers of Spring Integration Project, but as I just said, currently I'm a lead engineer for Spring Cloud Function, Spring Cloud Stream. The other presenters, Marc and Marc DiPasquale, will introduce themselves at their allotted slots later on during this presentation. So we have a lot of content to go through. So I'll begin right away in order not to waste any time. So here's a quick agenda. As you can see, there's three parts. So I'll go first. I'll talk about, quickly introduce you to Spring Cloud Function, to the whole paradigm of functional development and Spring Cloud Function. I will segue into AWS Lambda and Spring Cloud Function integration, and specifically talk about routing function. You may be surprised why all of a sudden I picked one of many features such as routing functions to talk about, but there's actually a connection with AWS Lambda, and I'll talk about that as well. Then I will hand it off to Marc from AWS Lambda team, who will talk to you about a lot of interesting things related to Spring Cloud Function, AWS Lambda, and yeah. And then the closing band will be brought to you by our friends from Solace with Marc DiPasquale on the lead vocals, who will talk to you about some very interesting streaming use cases when it comes to using Spring Cloud Function on Solace platform with another framework that I mentioned earlier, Spring Cloud Stream. So Java functions. So let's talk about the scope quickly. Here we're talking about Java functions. What is Java functions? That's the three core strategies that we got from Java 8, which is supplier, function, and consumer. And when I talk about them, I usually like to talk about to explain these sort of four parts to them, like simplicity, portability, extensibility, and consistency. So simplicity, it comes through the clarity of expression. No matter what we do, if you think about it, we either consume, produce, or doing both, right? And these three interfaces, these three strategies allow you to do exactly that, right? Portability. While there could be many different implementations of functions, at the end of the day, it is still either a function, supplier, or consumer. So any system that supports Java and Java functions will be able to port and interact with these with your implementations. Now, extensibility, as I already said, any interface could be extended. You can have custom implementations, but at the end of the day, it is still a function, a supplier, a consumer. So, and that brings sort of a consistency, the final argument, which is agreement with what has already been established, a very simple, well understood, widely supported strategies that don't come from Spring. They come from the platform itself, from Java, and we should all be familiar with them by now. So another interesting thing I'd like to talk about is the two core tenets when it comes to Java functions, which is the contract and the pattern. Contract, it defines a very strict set of rules, right? And pattern is greatly simplifies communication when it comes to interpreting business requirements, is you simply have to align a particular requirement to either function, supplier, or consumer. For example, receive and process receive and process debit and report new balance, right? This requirement, although trivial, is clearly a function because it talks about some input, talks about some output, right? But also notice how easy it is to get sidetracked by words like receive, words like send, right? Are we receiving via HTTP, for example, or messaging or Kafka or something like that? What about reporting? Are we going to be sending something somewhere? We get sidetracked by these requirements, but the reality is that those are non-functional requirements. Those are boilerplate things that we eventually, this is where that's sort of where a Spring Cloud function and other frameworks come to mind. But the function itself, think about it. Will the debit processing, like a debit transaction, would it be different if the input comes from HTTP or input comes from Kafka or input comes from somewhere else? Obviously, it's a rhetorical question. I can't, interact with the live audience at the moment, so I'll answer it myself, and it's resounding no. So no, the implementation should be absolutely the same. What should change is ability how you trigger, how you activate functions, and this is where we're kind of getting into the realm of Spring Cloud function. So, for example, as you can see from this slide, we can have many different execution contexts for the same function. It could be executed as part of AWS Lambda. This function could become an HTTP endpoint or a message handler, and many, many more. These three are just for to keep the slide pretty. There is gazillion more different ways of these functions to be. Various different ways to create execution context for a particular function. So, and this is where we're getting into a Spring Cloud function. So, what is Spring Cloud function? So, Spring Cloud function is a Spring Boot based framework. Now, again, the Spring Boot based, that's the important part, because right now everything is kind of Spring Boot. And by saying that something is Spring Boot based, that kind of tells you a lot of things about how it sets a lot of expectations. Like, for example, it means that there's going to be some auto configuration that will allow you to, for example, take certain assumptions. There are certain opinions that are going to be taken into consideration, while you can always introduce certain changes. So it is Spring Boot-based framework to promote implementation of business logic via Java functions. If you remember, like for those of you who are familiar with Spring and Spring MVC, we used to have back in the days when we talk about how you can create a POJO method and then throw a few annotations on it, and all of a sudden this method became an HTTP endpoint because the framework will took care of the rest, right? While you were able to do POJO testing without ever caring in the world that it could be invoked via HTTP. So we embraced a very similar paradigm here. So Spring Cloud function, like I said, promotes implementation of business logic via Java functions. It gives a uniform and portable programming model, integrates with other platforms, including the serverless, such as AWS Lambda, the streaming, Solace, RabbitMQ, Kafka, and many others. And as I already mentioned, consistency gives it consistency and testing capability. Some of the core features, oh, by the way, as I said, this is going to be very congested because like I said, we have a lot of content to present. However, so the Spring Cloud function part is going to take, I'm going to be done in about 10 minutes. However, if you want to get into more details, in the resources slide that's going to be displayed at the very end of this presentation, there is a link to my presentation from last year's SpringOne, where I actually had a whole hour to talk about Spring Cloud function. And that one goes into a lot of details and a lot more samples. So anyway, the core feature of Spring Cloud function is the most popular one is function composition. So like Rod Johnson once said, there is no such a thing as a complex problem. There is an array of simple problems. You just have to connect them. That's essentially what we're doing here, right? So instead of writing a lot of code, you can write a lot of code in isolated examples, test it individually, and then via pipe, we can connect them together and compose into a single function. Transparent type conversion. So you don't have to invoke function with exact type and worry about how to create this type. We'll take care of it for you. And that part of the framework is also extensible. If you don't have the appropriate message converter, you can create your own one. Reactive support. POJO function. In other words, the duck typing concept. If something looks like a function, like a functional interface kind of thing, then it's a function. Function array, which is functions with multiple inputs and output. Function routing, something we'll talk about today. POJO function, deployment of package functions, adapters, like function as this, function as that, and many more. So anyway, this is kind of what it looks like right now. So basically you create a bean, which is a function. You see a couple of examples. It just registers as a bean, and that's it, right? So we'll take care of the rest, and that's it. So you can see these are very trivial samples, but technically we don't care because we don't care what's inside the function. We only care about the signature because that's how the function gets bootstrapped around within the framework. So quick demo. I'm running a little short on time, so I'm going to skip. I'm going to skip one part of them. So quickly, here's basically the code. Here's a function configuration, 3 functions. And inside of my configuration, inside of my POM file, which is, again, when you work with Spring Boot, it's always your configuration class and your POM file, because that's where the dependency is defined. And dependencies are not just the libraries, they're auto configuration. So what I'm going to do is I'm going to uncomment these dependencies. By doing so, I'm basically saying I want to be able to invoke this function as a REST endpoint, and also want to be able to invoke this function as a message handler, for example, using Rabbit Binder. That's all I did, right? So I'm going to start it. And I'm going to go into my Rabbit console. You can see my, I can send the message, and you can see it's being reversed. And here I used actually function composition. You can see from here, and yeah. So this is, I'm going to remove this because I don't need it for another demo. I can obviously, you just saw how I send message to Rabbit, and all of a sudden it invoked the function. But what's interesting, I can also oh, what happened? I stopped it. I also as you can see, I invoked uppercase pipe reverse, and right now it uppercase. So the same function became a REST endpoint. So in other words, I could do, the function is the same, but all of a sudden I provide 2 different invocation and 2 different invocation and 2 different execution models, right? So now what I'm going to do is, I'm going to do the unthinkable, is that I'm going to execute CDK deploy, which means that Marc Sales will talk more about what is CDK and so on and so forth, but this is basically, we're switching quickly to AWS because I only have about 2 minutes to talk. So this will go through building and deployment all the way to AWS, which we're going to see in a second. But I'm going to switch back to the PowerPoint and quickly talk to you about AWS. So as one of the integration, oh my God, come on. So one of the integration points, as I mentioned earlier, is integration with serverless platforms such as AWS. So what Spring Cloud Function in AWS Lambda goals are ability to extend simple function programming model to AWS Lambda. So instead of writing the request handler, for those of you familiar with AWS, so instead of writing request handler, request stream handler, and various different handlers, you only have to worry about writing a function, implement a function. You can integrate with AWS Lambda API and tools, which is what I'm doing right now with CDK, and simplify management and maintenance of function as AWS Lambda function, such as routing function. So why routing function is so, because it has implication everywhere in streaming and in HTTP, but why is it so important in the context of AWS? Because AWS community requested it. Why? Because for those of you who are familiar with AWS, you can, when you define Lambda, you have AWS, you can expose it via an API gateway. But what if you have 10 functions, 10 Lambdas, 20 Lambdas? Can you imagine managing the 10, 20, 30 API gateways? Well, it's better to manage one, but have some way of saying, I want you to invoke this function or that function. And that's effectively what routing function does. So it's a function that simply routes to other function. It acts as a gateway firewall, single point of maintenance, dynamic composition, and so on and so forth. So I have about 1 minute, and perfect. Everything got deployed, and now we are in Lambda. So Lambda, here we go. Here's my Lambda was deployed, routing gateway, right? I can invoke it directly, or I can go through the API gateway. Anyway, I already have everything preset here. So I'm just going to execute another call request. So in this case, I'm posting to this API gateway. I'm specifically saying, I want you to invoke this function definition, uppercase reverse. And this is basically a cold start. So Marc Sales will talk a little bit about cold warm starts. right? So we're in the cold start point, and we're done. So as you can see, the output oof, so it uppercased and reversed the foo. So thank you very much, guys. I'm going to stop sharing. And like I said, we're going to hang at the other room after this for more questions. But now I'm going to introduce Marc Sales, who is my friend from AWS Lambda team. Marc, take it away.
Hi, everyone, and thank you for that great whistle-stop tour through Spring Cloud Functions. And I think it's really interesting to see the similarities between that project and Lambda. So just a quick introduction of who I am. So my name is Marc Sales. I'm a specialist solutions architect at AWS. I've been there about 3 years now, and recently I've been really trying to dive deep into Lambda and serverless and really connect with the community. So it's been great working with the people at Spring. So for those who are not familiar with AWS Lambda, what is it? Well, it's a compute service which allows you to run your code without having to manage any servers at all. So you upload your code to AWS, and we run your code in response to events. Now, very synonymous with what Oleg's just been talking about. So Lambda can be configured to work with many different event sources. So as he was talking about earlier, API gateway, but also messaging systems that you're probably familiar with. So Kafka, RabbitMQ, ActiveMQ, our own messaging systems like SQS and SNS, and a whole variety of other systems as well. Once a Lambda function receives an event, it's just like running code anywhere. So you can make connections to databases, you can make external calls. You're not really limited in what you can do. And although we're talking about Java today, you can run a number of different languages and run your own languages via something called custom runtimes, which we'll be looking at a little bit later when we come to talk about Spring Native. So one thing to understand about Lambda is that it has two components to pricing. One is the number of invocations that you make, and the other is the duration of the Lambda function execution. So you can determine how much memory is allocated to each Lambda function. And the price is dependent on how long the execution lasts for a given Lambda function for a given memory allocation. So the faster your Lambda function runs, the less you pay, which is great. So the core tenets for Lambda are shown here, and I think they're really interesting to talk about because I think a lot of them really associate well to each other. So we're always trying to produce the best platform for people to go to market the fastest. And people can achieve that by using our platform because we have so much of these architectural non-functionals already pre-baked into the system. So the system is already load balanced across multiple geographic locations. It automatically scales up and down with usage. We have billing, which is just on usage. So you're only ever paying for what you use. You never build for any idle time. And again, that fits in quite well with the total cost of ownership. But also the total cost of ownership works quite well with security. We're patching the system on your behalf and installing security patches. For me, this was quite evident when I was a customer because I remember using AWS Lambda as a customer, and a vulnerability called Spectre became known to everyone. And AWS Lambda was actually patched before that announcement was made. So for me as a developer, I could just carry on working, whereas other people around me were wondering what to do and how to patch the system. So security is really important for people using Lambda, and I'd just like to dive into that a little bit more because Lambda is a system that's used by hundreds of thousands of customers, invoking trillions of requests every month. So how do we keep all of these customers separate, and how do we make sure that your code doesn't affect other customers, and how does their code not affect your code? So what we do is we take a bare metal server, and we add our own micro VM. And this is from an open source project that we've started called Firecracker. It's freely available on GitHub. You can go check it out. And that uses a lot of open source technology and some of our own contributions to make a really minimal virtual machine, which starts very fast and is just specific for running Lambda and scale out systems like Lambda. In that micro VM, we add additional sandboxing so that the processes can only issue certain commands to the kernel. And then within that, we add your code. We have the runtime, which is Java in this case, and then we allow the customers to access some of the disk space. But that is a completely isolated environment compared to another customer who is in a completely different VM and isolated there. Okay, so this shows what an execution environment is, and the next thing I'd like to talk about is scalability. So one of the great things about Lambda is that you can use Lambda and you don't have to worry about scalability. So let's talk about that next. So I mentioned that Lambda doesn't have any servers. And how does it work then? So when you make a request, what happens is that behind the scenes, an execution environment is going to be created. So on that previous slide, I showed that an EC2 server has a micro VM. So one of those is going to be created. We're going to find a host with some spare capacity. We're going to make a new execution environment. We're going to download your code onto that environment. We're going to boot up Java, and we're going to load your code and execute your function. And that's all going to happen within seconds. And that execution environment will only ever handle one invocation at a time, which makes the programming model a lot easier. You don't have to worry about open file handles, things like that. So as requests come in, you're going to see that actually we need to make more execution environments. And this means that we're going to have a number of what we call cold starts, where execution environments are prepared, ready for use. But there'll be a point where there's a number of concurrent execution environments available, and requests will come in, and they will be able to be handled by execution environments that are already prepared. This is called a warm start. Now, as developers, we get hit by a lot of cold starts because we're making changes like Oleg did. And we're making changes, uploading our code, and then testing our code. The vast majority of customers will always hit warm starts because the system will be up and running. And as the requests come in, they will be shared across a number of execution environments which already exist. So as developers, we get a poor story, but that's how it is. And how can Lambda scale? Well, Lambda can add execution environments up to a number of different limits. And we're just going to talk about the limits just now so that we can understand the scale which we can operate at. So by default, AWS accounts in each region can have a concurrency of 1,000. So that isn't 1,000 requests a second. If your requests take less than a second to execute, you can have a request per second much higher. So say you had 1,000 concurrency, 100 milliseconds per request, that's 10,000 requests per second. The other thing to think about is what we call burst capacity. So burst capacity is how many execution environments you can add in a short period of time. And the different regions are different sized, which means we have different burst capacity in different regions. So in Ireland, where I typically operate my test from, I can burst up to 3,000 execution environments in a minute if my account limit has that a limit as well. Obviously, these can be changed with support tickets. So if you're finding that your workload is using more than 1,000, which is the default account limit, raise a support ticket and that can be adjusted for you. Okay, so obviously, in this sort of architecture, cold starts are really important. Every time we hit a cold start, we're adding latency to the system that's affecting our customer's journey and our customer's likelihood to continue that journey. So what exactly happens in a cold start, and what can I do to optimize for this? Well, your code is downloaded from S3, which is where it's stored, which is our storage service. A new Firecracker micro VM is started, the JVM is started, your application is loaded, then your function is invoked. Well, there's a lot of different stages there which you can look into optimizing your code for, and that is a whole talk in itself. This is where I would normally talk about these things, but I'm actually going to be talking about Spring Native instead. So I'd invite you to have a look at this talk by one of my colleagues from Germany. I think it's a really good, very in-depth session about how to optimize Java applications. The alternative now is that we can use Spring Native, and I'm going to show how the performance is quite different to how it was before Spring Native. Okay, so let me switch over. Check my time. Yeah, we're good. Okay, so if I swap over to IntelliJ and change my sharing, share IntelliJ. Okay. So Oleg was kind enough to supply me with some code. So he gave me a Spring Cloud function which does some uppercasing. This is the implementation. And what I've done is I've used a project that he mentioned in his talk called CDK. So CDK stands for Cloud Development Kit. And what it is a way of expressing AWS infrastructure as programming code. It's available in a number of different languages, and obviously I'm working in Java here. So this is a Java variable which describes a Lambda function. So when Oleg typed CDK deploy, what was happening was this application was running, which is a Maven project, and was producing descriptions of the infrastructure he wanted, and then executing on his behalf into his AWS account using his credentials. One of the neat things about this is that I can also tell it to find the code from my class path or my local machine, or I can tell it to use a Docker container to do the build. And because I want to be a good citizen in my development team, I'm going to use a Docker container to do my builds so that I can have the same Docker container for multiple people. So this section of the code describes what Docker container I want to use. I want to map my local M2 directory so the builds don't take a long time. And then at the top here is a list of arguments that I want the Docker container to execute. And the bit that is most interesting is this bit. So we're doing a Maven clean package. And as you've probably seen from other talks in this conference, we're adding this new profile, which is native, which is telling Spring Cloud functions to package in using the native functionality. So for those not aware, it's using GraalVM's native image tool behind the scenes to produce a native binary of our Java code. And this has the advantages of being a much smaller footprint, which is great for Lambda, being such a constrained execution environment. And it has a really, really fast startup time. So anybody who's used Spring Native will know that one of the downsides is that the compilation times take a bit longer. So in this demo, I won't be able to show the compilation times because it takes a few minutes, but I've prepared one already. So I'm just going to show you a quick demo of that. So if I switch over to my console screen. So now we're in the AWS console. I have a Lambda function called uppercase, and I can explore the Lambda function as I normally would do. In this case, I have a memory setting of 256 megabytes, which is quite low if you've ever used Lambda on Java. And unlike Oleg, I'm going to use the console to inject an event. So this event is going to say, hello, Marc, and we're doing uppercasing. So if everything goes well, I should get a response that says, hello, Marc in uppercase. So this is the first time I've invoked this function. So I have a cold start, and a cold start in the console is called the init duration. So if you ever see init duration, that's a cold start. Now my cold start was less than 500 milliseconds. If I was using Spring Cloud Functions without Spring Native, I would probably expect to see 2, 3, 4 seconds maybe. So we've really taken a good chunk of the time here. Now, after the cold start, I can execute the function again. Oh, the beauty of live demos. So there's obviously been a problem here, and let me just force another cold start and see if I can show you that again. Okay, that's timed out. So this should be my cold start, less than 500 milliseconds, and my warm start. There you go. No cold start, and then a much faster warm start duration. So there you go. And that's my demo. Thank you very much. Back to Oleg.
Thank you, Marc. That was very interesting and blocking out in terms of words, but yeah, it was extremely interesting and useful. And of course, the demo gods, had their say. But anyway, I hope you guys enjoyed the AWS and Lambda and all the interesting things about it. But right now, we're going to switch completely the context and go into the world of streaming with Solace as a messaging platform. And I'm turning it over to Marc DiPasquale.
Hey, Oleg. Hopefully everybody can hear me now, and you should see my screen. So I'm Marc DiPasquale, and I'm a developer advocate at Solace. So for those who are not familiar with Solace, Solace is a technology provider where we offer a platform to enable organizations to design, implement, and operate event-driven architecture. So along those lines, I'm going to talk about how to use Spring Cloud Function. Of course, that's the topic of this talk, with Spring Cloud Stream to create event-driven microservices that we see a lot of customers using today. And so as part of that, Oleg mentioned earlier that Spring Cloud Functions can kind of be written once and have them invoked and activated in many different ways. So we're going to look at using Spring Cloud Stream to kind of implement the streaming part of this. And so I'll jump in and give a quick intro to Spring Cloud Stream. So if you're not familiar with Spring Cloud Stream, it is a Spring project that provides a framework for creating these event-driven microservices that can be used with pluggable messaging systems. So at the bottom of the image here, you see Kafka, Rabbit, Amazon Kinesis, and of course, Solace PubSub Plus. There are a few others as well that you can check out on the project page. So all of those are pluggable via binders. You don't have to worry about using their specific APIs, but you just learn how to use the Spring Cloud Stream framework. And then the binder handles the communications with the broker itself. The project is based on Spring Boot, and it uses the foundation laid over the years by Spring Integration and Spring Messaging. Of course, the code, as we'll see, is now written in Spring Cloud Function as of version 3. And there are 3 different application types. So you can see on my screen, we kind of have a source application type. So these apps are ones that publish events into your event broker of choice. On the right side of the screen, you'll see a sync application type. And these are apps that are receivers or consumers of those events. And then in the middle, we have the processor application. So the processor applications are a combination of the two. They consume events, apply your business logic, and publish usually related events. So that's like the quick intro to Spring Cloud Stream. As I mentioned before, it is an abstraction framework for the events, so you don't have to learn the messaging APIs themselves. You just have to kind of learn the communication models that you want to use. So the framework supports 3 different communication models. One is persistent publish subscribe. So this allows your subscribers to be independent from each other and receive all of the events in order in a specific stream. The second is consumer groups. So consumer groups allow for you to fan out and load balance events across multiple consumers that participate in a given group. And the third is stateful partitioning support. And so that model allows for in-order processing for consistency and performance. And then to bring it back to Spring Cloud Function, we write the code for Spring Cloud Stream now using Spring Cloud Function. And so all those functions that Oleg mentioned earlier, your Java util function supplier, function, and consumer that were introduced back in Java 8, map to those Spring Cloud Stream application types. So you have your supplier, which is your sender or your source of events. You have your function, which implements the processor pattern. And you have your consumer that is your, of course, receives messages and processes them, right? And so on the screen here, we can see an example of what a Spring Cloud Stream app using Spring Cloud Function might look like. It probably looks pretty familiar because you've now seen something similar from both Marc and Oleg. But we just have a simple uppercase function, and that uppercase function is receiving a string and outputting a string. And nothing here looks like any sort of messaging code. And so I just wanted to quickly demonstrate how this might work. So I have that same function here in my IDE. And as Oleg mentioned earlier, in order to kind of invoke your Spring Cloud Function via Spring Cloud Stream, in your POM, you just need to include the right dependencies. So remember, this is a Spring Boot app. So Spring Boot kind of knows to check for the dependencies and see what's there and do the auto configuration for you. So it sees that I have Spring Cloud Stream included in my POM and the Spring Cloud Starter Stream Solace, which says, hey, the Solace binder is available to check. And that binder is what knows how to use the Solace messaging APIs to send and receive messages. So if I run my app, I'm going to run it as a Spring Boot app. I'm just using Spring Tool Suite here to run it. This will go ahead and start up. I can see my application is run. And I'm going to go ahead and invoke my app. And so what's going to happen here is I'm going to send a message in using a Solace tool that is going to arrive to our application via the uppercase N0 topic. So that is kind of the default topic configuration for this function. You, of course, can configure that to be what you would like, but we're going to stick with the default for the demo. The function will then take the payload of that message, treat it as a string, uppercase that string, and return that string from the function, which Spring Cloud Stream then, in conjunction with Spring Cloud Function, puts that in the message payload and sends it back out onto the uppercase out0 topic. So just to show that, I have this try me tab in the Solace Pub Sub Plus manager. So this allows me to send and receive test messages with Solace. I'm going to go ahead and connect a subscriber and a publisher. And I'm going to listen on uppercase out0. Go ahead and subscribe there. And I'm going to publish on uppercase N0. And so I have a local Solace broker running. It's a Docker container. And so by default, the Spring Cloud Stream knows how to connect to that via the Solace binder. So I don't have to configure any sort of connection information. And we'll say, hello, SpringOne. And I'm going to go ahead and publish that. And I can see that my subscriber did indeed receive the fully uppercased message on the subscribing side. And in our application, we can see it did indeed process that message as well. So that is the very simple introduction to Spring Cloud Stream. I will say, if you want to learn more, I highly recommend you check out Oleg's talk from last year. It will be in the resources slide at the end of this talk, and we'll supply the deck in the Slack channel. Also, the Spring Cloud Stream reference guide is really the documentation for the project. I highly recommend going in there if you have any questions. It has very detailed information on how to use all the different features of Spring Cloud Stream. But for the rest of the talk, I want to talk about a feature that's kind of near and dear to my heart, working at Solace and with a lot of organizations implementing event-driven architectures. And that is how these organizations are using dynamic destinations or topics, and also how Spring Cloud Stream allows you to do that as well. And so we refer to these as dynamic destinations in the framework. For many brokers, those destinations are topics, right? And so you might say, Marc, why is this near and dear to your heart? And the reason for that is because dynamic destinations really allow for improved decoupling. So one of the main reasons that organizations adopt an EDA or an event-driven architecture is that it promises a more decoupled system that allows, for easier scaling and easier extensibility, et cetera. But just adopting an EDA doesn't guarantee this. You need to have a proper design that doesn't tightly couple your event-driven apps, just like their synchronous predecessors. And so dynamic destinations can go a long way to provide a flexible coupling point. And what do I mean by that? Well, producers publish to topics and consumers subscribe to topics to receive the events that are being exchanged. And so in an event-driven system or event-driven architecture, these topics are really the coupling point of an EDA. So if we can make this point flexible, then we allow that coupling to become as loose as possible. So as an example, you can use a hierarchical structure allowing for different levels. And so, one of the, in Solace and MQTT and IBM and a lot of the messaging systems that are out there, you'll use a / to delimit these levels. But then once you do that, each level can be a variable or an enumeration that is derived from the data itself. So this allows you to use that topic name as the channel, and it allows you to really describe the contents of the messages. So in the example here at the bottom, this is a Internet of Things or IoT connected vehicles example. And so we have 6 different levels of our topic. The first level is really which app is it? In this case, it's the bus tracking app. The type of event or message that's exchanged over that channel. In this case, it's a GPS update. And then we have the bus number, the route information, the latitude and the longitude. So this allows for your topic to be very specific about what this message is, which is great. So publishers can really publish something out that describes exactly what the contents of the message are. So publishers are publishing to that topic and they don't care what the consumers are doing. Then if we think about that from our IoT connected vehicles perspective, the consumers can look at the stream of events, that might be an infinite stream of events, and say, okay, which events do I want? Do I want all those events? Do I want some of those events, et cetera? So in this case, subscriber number 1 might say, you know what? I only want the events for bus route number 10. Whereas subscriber number 2 might say, you know what? I want to consume all the events that are near the airport. And you might then have subscriber number 3, which might also be a consumer group of applications that says, I want to consume that entire stream. Maybe I want to consume it all now and do analytics on it. So by using the hierarchical topic structure, this allows for all of those things to happen without the publisher having to change. Like each of those subscribers can choose the subset of the stream that they want to consume without having to say, hey, Mr. Publisher, can you publish to this other topic or change the partitions that you're publishing to? Instead, these consumers can look at that well-defined topic hierarchy and use wildcards to decide what exactly they want to consume. So in the middle of the screen here, we can see if you want to consume all data from all the buses on Route 95, you can use wildcards at specific levels and then specify, for example, Route 95 at the route level. Or our second example there was, I want to receive all the messages near the airport. Well, you can define a bounding box and then in your topic subscription, define like what latitude and longitude you want, and use wildcards to represent, even part of a level as well. And so this allows the consumers, again, to decide exactly at a fine-grained level what events they want. And then the broker does the filtering for them. So I want to point out here that, one of the benefits of this is that each of those applications are only getting the events that they subscribe to. They don't get all of the events and then throw 90% of them on the floor that they're not interested in. They only get that 10% of the stream, for example, that they want, or the 100% of the stream that they want, or the 45% of the stream that they want. And I wanted to show a quick example of this, actually. And so fitting with our bus example, one of my colleagues created a real-time connected buses demo, and it's a demo of buses driving around Singapore, right? And so all the buses, we've got, I don't know, a couple hundred buses there, all publishing GPS updates on a topic hierarchy. And so I then have this web app that's a subscriber of these events. And so right now I can see it's, receiving, 100 to 175 messages a second. But, what if I wanted only buses on Route 10? Then I can change my subscription and say, I only want to subscribe on Route 10. And in real time, the broker says, okay, you're only interested in events on Route 10. I'll zoom in a little bit. And now I'm only receiving buses on that route, right? And if I click on one of these buses, probably a bad example behind that, I can see that the topic string here, there's a Route 10 in here, and that's what I'm filtering on. And I can see that Route 10 kind of goes from the west side of the country across to the east side. And so I can see only those buses. Whereas our other consumer, let me go ahead and bring all the events back in. Our other consumer might only be interested in one area of the country. And so he or she or the application could say, you know what, I'm only interested in events over here by the airport. Let me create my bounding box and subscribe to only events there. And so now I can see the buses on the rest of the map start to disappear because I don't care about those events. The broker is only sending me the events for the buses in my area based on what I'm saying I want to subscribe to. And I can see my received message rate is now down to 20 messages a second. So I'm not receiving those other 120 messages and throwing them away. I'm only actually receiving the events that I am actually interested in. So you can see, here, like that well-defined topic hierarchy really allowed the consumers to filter on exactly what they wanted. Obviously, I didn't have to go to each bus and upgrade their software and tell them to publish to a different topic, for example. All right. So now that I've showed you a working example, obviously that map was not using Spring, but in the Solace event broker and other event brokers, right, there are protocol translations and stuff like that. So I can consume those events in Spring CloudStream or publish events in Spring CloudStream and consume them in an MQTT app like the one that I just showed. So how exactly do I publish to dynamic topics using Spring CloudStream? And there are multiple ways that the framework supports for this. The first is using StreamBridge. And StreamBridge, as you can see on the screen here, allows the developer to work with just the POJO or the plain old job object. You'll notice, in the function here, I'm not actually dealing with the message object at all. And so you can inject the StreamBridge object here, and then in your Spring Cloud function, you can use StreamBridge.send. You specify the topic you'd like to send to, and then the payload of the message that you would like to send. And this allows me to have a method such as the get my topic using logic method to apply your business logic and define that dynamic destination that you might want to publish to. So in our example, a second ago, the bus would check its GPS location and say, this is my latitude, this is my longitude, this is my bus number. It will build that topic and then publish to that. Something to call out here is, when you do use StreamBridge, Spring is managing each topic as its own Spring integration channel, which is useful for metrics. You can then query via JMX and stuff like that. And Spring CloudStream will also cache a configurable number of these channels. I think the default is 10 or 20, but you can configure that if you know you're sending to the same 5 places or the same, 50 channels. So that's the first option. Option 2 is using a few special headers. So the first of these headers allows the dynamic publishing to be handled at the framework level itself, and that is the Spring Cloud Stream send to destination header. And the second of these headers allows the dynamic destination resolution to be handled by the binder. And so that takes away a little bit of the framework overhead. On the second one here, you definitely want to check and make sure your binder supports that. The Solace binder is an example of one that does. But if you go this route, now you're actually dealing with the message object because we are adding a message header. And so again, you can define the topic or the destination that you want to publish to using your business logic. And then, define your payload however you want. But then when you're actually going to return to send the message, you're going to return a message object. And on that message object, you're going to set the header. In this case, I'm doing the binder header's target destination header, but you could also use the Spring Cloud Stream send to destination. And so by doing that, every time you execute this function, your business logic could be different and you could be publishing to a different topic. And so that allows you to publish to the two dynamic destinations, which is becoming more and more popular. I actually just had a question on it from a customer about 30 minutes before our talk. So, all right. How much time is left? Looks like I've got a few minutes. So this application here is going to be available afterwards in the GitHub repo. But I actually implemented these as well in the same class. So you can uncomment and comment out and test these out. So I've got the stream bridge option here, and I've got the target destination option. I'll just show one of them real quick since there's only about a minute left before I hand back to Oleg. And so essentially, this is going to consume a message from the function using stream bridge in0 topic. That's the default topic. It will execute my get my topic using logic, which is simply just going to publish on hello SpringOne and then a counter, which I think starts at 1 or starts at 0. So let's check it out. So if I go back to my try me tab, clear my messages, I want to subscribe. I'll just subscribe to everything real quick. Stop. Case in 0. Actually, I don't want to subscribe to everything. I want to subscribe to hello SpringOne. All right, and if I publish hello SpringOne, I see that my hello SpringOne was processed by my function, and it's dynamically adding this 0 on the end. If I change this to my second message, it's now publishing to hello SpringOne/1, and I'm subscribing using the greater than here, which is a wildcard in Solace. So as I keep sending this, I can see here the topic changes, and I'm subscribed to all of those. So that is how you send to dynamic destinations using Spring Cloud Stream. So just a quick takeaway there from this talk as a whole. Spring Cloud Stream allows for you to invoke and activate your Spring Cloud functions for streaming use cases and provides functionality like publishing to dynamic destinations that allow you to solve a lot of these real world problems. And then if you want to learn more, we have office hours at the Solace booth until 1 p.m. But obviously, we have our Q&A session right after this that we'll be jumping into. So back to you, Oleg.
Thank you, Marc. This was actually very cool because as much time as I spent with you, I've learned something and I got excited about something. It's interesting to see that at the end of the day, functions remain the same. Spring Cloud Stream is the same, but the topology of topic names, the queue names that Solace provides allow us for completely different use cases, yet still using the same frameworks that are used for other use cases. And obviously still using the same functions, still using the same functional implementations that have nothing to do, have no knowledge of your topology, have nothing to do with specifics of Solace or AWS Lambda or anything else of that nature. So we're actually doing very good in time. We still have 45 seconds to talk about anything. So what I'd like to talk about is simply say, here's the slide with all the resources that are relevant to this presentation. There is a link to GitHub repo, which is also included in the Slack channel for this talk at the as a pinned message. You can see, basically, I'm not going to describe every single link. You just click on it and figure out what it does, but it's all relevant to today's presentation. I would like to finally, who we are and how to get in touch with us. The link contains the PDF of this presentation, which actually has these slides with each slide for each speaker with our information. So, and with that, I would like to thank Marc and Marc. And thank you guys.
Thank you, Oleg.
Wow, what a great presentation there by Marc, and Oleg. I certainly learned a lot listening to that, even though I'm part of the Spring Cloud team. But yeah, it's hard to keep track of everything. There's some great demonstrations there, Spring Cloud Function, and really enjoyed listening to that presentation. It's a great job, guys. Everyone grab another coffee and get ready for some more content coming right up.